So today we're going to look at standard form. And with standard form, it looks a little different. Standard form looks like this. Y is equal to ax squared plus bx plus c. And we're going to be using these coefficients a, b, and c today as we find standard form in order to graph it. This is a pretty slick way too. So we've done vertex form, we've done translations, now we're going to do standard form. So we're just going to follow these steps in order to see how to graph it. So we're going to graph this equation, y equals x squared minus 6x plus 9. The first thing we're going to find is the axis of symmetry. Now, we are going to find the axis of symmetry, but at the same time, of course, we're going to find the x-coordinate x-coordinate of the vertex. And there's a formula for that. It is negative b over 2a. So negative b over 2a. So here, a is 1 and b is negative 6. So we're going to plug that in, and we're going to find that that's negative b over 2a, which gives us 6 over 2, which is 3. So that is the x-coordinate of our vertex. But, okay, so down here it says vertex, so far we have a 3. Because that is the x-coordinate of the vertex, that is also our axis of symmetry. Remember, our axis of symmetry is x equals whatever x is. So there's our axis of symmetry. And we can actually draw that in right now. So the axis of symmetry is x equals 3. So here's our axis of symmetry. And we know the vertex is going to be on this line. So what we're going to do now is we're just going to go find that. So to find the coordinates of the vertex, we're going to calculate the y value by, of course, plugging the x in. So we have our equation, y is equal to x squared minus 6x plus 9. We're just going to plug the 3 in, and then we're going to find y. So this formula is one you want to memorize. The x-coordinate of the vertex is negative b over 2a. That is the x-coordinate of the vertex. So we get 9 minus 18 plus 9. Oh, well, look at that. That's going to give us 0. So our y-coordinate is 0. Therefore, we can now plot our vertex. Our vertex is 3 and 0. There's our vertex. Okay? Now, we can't go off the parent function and just plot it from that. We have to keep going. We have to determine what is the direction of the parabola. And remember, A determines that. If A is positive, it opens up. If A is negative, it opens down. We know that A is positive. So A is 1, so this parabola will open up. Now, if possible, find the y-intercept. And the reason we say if possible is because sometimes our y-intercept is not within our grid. It might be 15, it might be 25. But we're going to find it as much as possible. In order to find that, of course, how do I find the y-intercept? That's right, we plug 0 in for x. Same thing we're going to do here. To find the y-intercept, we're going to plug 0 in for x. And remember I told you when we first started doing y-intercepts, that's going to be important. Okay, so we're going to plug 0 in for x. Our y-intercept, let's write down our equation again, x squared minus 6x plus 9. That's our equation. We plug 0 in for x. And notice everything drops off but this number, our constant. Okay, so when you substitute x then into the equation, y is equal to 9. Now look at that. Where else do I see 9? That's right. That's going to happen every time. That's not an accident, because when you plug in 0 for these other two where there's a variable, they're going to drop out. So the y-intercept of a quadratic is the value of c. Whatever c is, that's going to be it. Don't worry if you don't memorize that one, because you can always just plug 0 in. Always remember how to find the y-intercept. If you remember it's c, that's great. So the y-intercept of our parabola is 9. I don't know what that blank was doing. Okay, so now, doesn't matter. Moving on, I'm going to plot the y-intercept at 9. So I come up here, 1, 2, 3, 5, 6, 7, 8, 9. And see, our y-intercept barely even made it on this one. Now here is, and I'll show you this, we plot the y-intercept, and then we're going to reflect the point over the axis of symmetry. So remember we talked about the y-axis as the axis of symmetry. It's also the reflection line. So see how I'm 1, 2, 3 away here? This axis of symmetry reflects. So if I would fold on that axis of symmetry, I would see that it would also be 3 away here. So whatever distance the y-intercept is, I'm going to have another reflection point on the other side, so I plot that. Now, I like to have 5 points, and so again, what the directions say, find 1 or 2 more points by choosing an x value near the vertex. So here's our vertex down here. Choose an x value, and it doesn't matter which side you're going to be on. So 2 is a good number, 1 is a good number, and we're going to plug those in. Okay, so I'm going to plug in 1 because I think that's easier. So in my equation, y equals x squared minus 6x plus 9, and I am choosing x to be equal to 1. Why did I choose that? Because it's close to the vertex, and it's a small number. Okay, sometimes I can choose 0 depending on where my y-intercept is. I can't on this one. Okay, so, wait, no, because we've already used it for the y-intercept. Ignore what I just said. Don't choose 0 because that's going to be your y-intercept. Okay, so here we go. We're going to plug in 1. We have 1 squared minus 6 times 1 plus 9. 1 minus 6 plus 9 is going to be 10 minus 6, that's 4. So what we just found out, when x is 1, y is 4. So we're going to plot that point. X is 1, y is 4. 1, 2, 3, 4. Okay, now here we go. See, and this is what I call buy one, get one free. You find one point, you get its reflection point free. So if you find 1 point, you get 1 free. I'm 2 away here, so I'm 2 away here. There's my 5th point, and now I'm going to draw in my graph. And make sure it's a rounded bottom, and comes right back up. Okay? So this gives you all the steps. Plot these points, draw the parabola. So remember, this is your buy one, get one. Okay? You get a y-intercept, you find the y-intercept, you get 1 free. You find a point, you get 1 free. So it's a buy one, get one. Okay, let's go to the next page. Oh, I'm so sorry. I forgot to tell you that we were on page 23. Hopefully you figured that out. Okay, so now we're going to practice another one. Okay, and we're also going to talk about max and mins. And I know we talked about this before, but I want to look at this. So when A is 1, that means that it's opening up. If it's opening up, my lowest point of this is going to be my vertex. So I know that this is going to be a minimum. Okay, this is a minimum. I always forget to go over that. I apologize. So here we go. Let's find out what's happening here. And they do sometimes, this note sometimes does it in a different order. It says find out if it's a max or a min. So what I do is I look at this and I'm going, okay, A is equal to -3. And also that means that it's going to open down. And I just do a little sketch. I'm like, oh, okay, that's opening down. So where's my vertex? It's my highest point. So that means this is a maximum. So you just kind of draw yourself a story there. Okay, let's find that axis of symmetry in our vertex. So we're going to use that x is equal to -b over 2a. So a is -3, b is 6, c is 5. Oh, hey, remember that bonus? Do you remember when c is 5, what's my y-intercept? Exactly. So it doesn't ask for that, but we're going to write it down. Y-intercept is 5. Okay, our y-intercept is 5. We can actually plot that point right now. 1, 2, 3, 4, 5. That's our y-intercept. Okay, let's go find our vertex and our axis of symmetry. So we're going to plug in here, and we have -b, so -6. And I always put it in parentheses just so I don't have to worry about my signs there. 2 times a, so I get -6 over -6. So my vertex, my x-coordinate is 1. My axis of symmetry is an equation, so x equals 1. We have my x-coordinate. Let's go and find the y-coordinate. So y is equal to -3 times 1 squared plus 6 times 1 plus 5. -3. That's a -3. Just to be clear on that, that's a -3. So that's going to be 3 plus 5, that's 8. Okay, so my vertex is 1, 8. That means I could have drawn in my axis of symmetry. I forgot to do that too. So here's my axis of symmetry. And that's what I mean by the order doesn't completely matter. Because right now I could be finding out my y-intercept. So you always want to find out your y-intercept even if it doesn't ask for it. And that's always going to be C. But if you forget that, if you forget how to find your y-intercept, remember, just plug 0 in. Okay, so now let's plot our vertex. Our vertex is 1, 8. So there's our vertex. Hey, now that we have our axis of symmetry, we have our y-intercept. So here's our buy one, get one free. We have the y-intercept. It's one away here, so we're going to go one away there. Okay? Now, you have to choose a point in order to find this. Oh, what is this stuff? This is sometimes helpful. Translations. It's wide, narrow, or neither. Well, A, okay, look at A. A is 3, so if A is 3, then that means that it's going to be narrow, going to be narrower than my parent function. Does it translate up, down, or neither? We don't care about that. That's helpful when I'm in vertex form. It's just that you'll find on all these worksheets they do that, so it doesn't matter. We'll come back to domain and range in just a second. Let's finish graphing this. We need 2 more points. So let's do our buy one, get one. Let's pick an x value. So a good x value would be -1 or 3. You can do either one. It doesn't make any difference. I'm going to choose a positive because I do so poorly with negatives. So my equation again is y is equal to -3x squared plus 6x plus 5. I am choosing that x is equal to, I decided on 3. You can choose whatever you want. So I have -3 times 3 squared plus 6 times 3 plus 5. So 3 squared is 9 times 3, that's -27 plus 18 plus 5. So take away 5. I'm sorry, I have to do some more work. So I'm going to take away 5. That gives me -22 plus 18, 18, 19, 20, 21, 22. So 4, I get a -4. Okay, so I use the 1, 2, 3. I'm over here. So x is 3, y is -4. So I'm going to go 1, 2, 3, down 1, 2, 3, 4, right there. Okay, buy one, get one. I found one. I worked for that one. I'm 2 away, so I'm going to go 2 away here. Wow, that is a narrow function. Look at that. Look at that graph. I'm going to go like this and start there and then come down so I can kind of see where it's going. Okay, so there's my graph. Hey, let's go back and talk domain and range. What's the restriction on my x value? Nothing. So this is all real numbers. So this goes from -infinity to infinity, or you can say all real numbers. Okay, let's talk about range. Range, what are my y values? Well, I can't go above 8. I can't go above 8. That's my highest point because it's a maximum. So my range is y is less than or equal to 8. So therefore, in interval notation, that would be that it goes from -infinity, because it's way down here. I can have a -infinity, and it goes to 8, but 8 is included, so it's a square bracket. Okay, I'd love to have you turn off yours right now and try this one. So I would suggest it, strongly suggest it, but I'll let you decide. Why don't you at least try to go through and find if it's a maximum or minimum? What's my axis of symmetry and what's my vertex? Remember, we're ignoring this part. We don't care. We could even answer that question right now. Look at your graph. Look at this. Okay, so we're going to pause and you're going to try that. Go. So hopefully you actually did try that. What I was saying earlier is that we can determine right away if this is wide, narrow, or neither in comparison, because A is equal to 3. So that's a whole number, so therefore it's going to be narrow. Wow, we must have liked the 3s. Was on the last one too. Okay, so now we're going to look at this. I'm going to just sketch it. A is positive, so that means it opens up. If it opens up, my vertex is my lowest point, so this is a minimum. Max and min are based off your vertex, sorry. Max and min are based off your vertex. Let's find that axis of symmetry. So B here is 12. We're going to use our formula that x is equal to -b over 2a. I'm going to write that every time, so hopefully we remember that. So -b over 2a gives me -12 over 6, which is equal to -2. So my axis of symmetry, x equals 2. My vertex so far, I have, oops, that's a -2. That's going to make a huge difference. That's a -2. That's going to be a -2 there also. Watch those signs. Okay, so -2. Go ahead and draw in that axis of symmetry. -2. So my axis of symmetry is right here. And hopefully you were able to do that. Okay, so now we're going to find the x-coordinate of the vertex, or we could have find the y-intercept. And that's where it doesn't make any difference. Because what's our y-intercept? Do you see it? Yeah, because you plug in 0 here and 0 there, it's going to be C. It's always going to be 8. So my y-intercept is 8. Wasn't my y-intercept 8 on the last one? No, that was my vertex. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8. And there is my y-intercept. 1, 2. Okay, buy one, get one. Since we have our axis of symmetry, I have 2 away here. I'm going to go 2 away there. So I already have my y-intercept. Now let's go find the rest of that vertex. We have the x-coordinate, so let's find the y-coordinate. So I'm going to plug it in. Y is equal to 3 times negative 2 squared plus 12 times negative 2 plus 8. Our vertex is going to be way down here, isn't it? So that's going to be 4 times 3, which is 12, plus negative 24 plus 8. So 12 plus negative 24, that's a negative 12, plus 8, that's going to give me negative 4. Okay, so my point is negative 2, negative 4. There's my vertex. Okay, and now we need to find a point. What would be a good one to plug in? Well, you want to usually go between your y-intercept. See how my y-intercept, look right here. My y-intercept is right here, and here's my vertex. So I would either pick negative 1 or negative 3. Negative 1 or negative 3. I'm going to go with the smaller one. This time I have to go negative. So I'm going to plug in a negative. I'm going to choose x is equal to negative 1. That's the x value. I'm going to go find the y value. So 3 times. Now I will tell you, this is where function notation is awesome, because I could just write f of negative 1, and I know my x value is negative 1. So that's where function notation is really great. It's telling you what your x value is here. You don't even have to write that down. So negative 1 squared, where's my equation? Plus 12 times negative 1 plus 8. Well, 3 and 8 is 11, so 11, that's a negative 1. So my other point is negative 1, negative 1. So that's my x value, that's my y value. X value, y value. So negative 1, negative 1. If that's my point, now you get to get one free. So 1 away here, 1 away there. Okay? So draw in that one. Again, this one's going to be narrow also because of that 3. So we know that we did it right. It's going to be narrow. Good. Okay, so this is your homework. It's going to look very much the same. Again, this part we're not going to worry about right now, how it translates compared to the parent function. But it never hurts to help. Look at this. If my parent function's here, it went over to the left 2 and down 1, 2, 3, 4. Now, the beauty of knowing vertex form, I could write the vertex form right now if I wanted to, because I know A is 3, I have my vertex, I could actually write it in vertex form. Oh, what the heck, let's just do it. So my vertex is negative 2, 4. Here is my A. So vertex form, if I were writing this in vertex form, would be y is equal to 3 times, remember vertex form, A times x minus h quantity squared plus k. So that would be x minus that one, so it would be negative 2, because that's h, plus negative 4, so let's clean that up. Y is equal to 3, oops, hey, x minus. So x plus 2, quantity squared, minus 4. Minus 4. See how vertex form is so cool? Once you have the vertex, you got your equation. Hey, while I'm here, I forgot to do domain and range. What's my domain? That's right, that's all real numbers. Or you can write it as negative infinity to infinity. What's my range? What's my lowest y value? Negative 4. See how my y-coordinate of my vertex is going to determine your range. So y has to be greater than or equal to negative 4. So in interval notation, it's going to go from negative 4 on up. Okay, but that y-coordinate, look at that y-coordinate of your vertex, is going to give you your range. So everything works together. It's pretty cool. Okay, so over here again, you're going to go through, find your max and min. Do it just like we did here. Okay, what's A? Sketch a little graph. Sketch a little parabola. Find your axis of symmetry using your formula negative b over 2a, which also gives your x-coordinate. Find your y-intercept. Always find your y-intercept. What's your y-intercept? Your y-intercept, yep, that's right. It's going to be always going to be equal to c if I have it in standard form. Okay? Is it wide or narrow? That you can determine right away by figuring out what A is. Okay? It's on this one. Look at this. I'm doing some of your homework. A is 1. So if A is 1, it's neither wide nor narrow. It's just the parent function. So that is just normal. Maybe we should put normal instead of neither. Wide, narrow, or normal. So think of it that way. Okay? Go through and do the rest of it. Graph those. So you should be in good shape. Doing those 6 problems is what we want you to do for homework today. Great. Hope that helps. If you need to, rewatch it. Thank you so much. If you have any questions, you know where to find us.